Hello, in this video I'm going to solve problem number 4, paper 3, STEP exam 2018. So let us read the problem first. The point P with coordinates A secant theta and B tan theta lies on the hyperbola x squared over a squared minus y squared over b squared equals 1, where a is greater than b greater than 0. Show that the equation of the tangent to the hyperbola at P can be written as bx minus ay sine theta equals ab cosine theta. If you don't mind, before continuing the problem, let us do this first part together. That would be a very good idea if before each step you pause the video and give it a try yourself. Okay, so let us start the first part. Okay, so function is actually a curve is given to us. We know that this doesn't define a function because for each value of x you will have two values for y, so that's not a function, it's a hyperbola, but the idea of the tangent line to the curve is more or less the same. And this point is given on the parabola. It is very simple to really check that if this point indeed lies on the parabola or not. To do that, of course this is not part of the problem, but just to learn more, I want to really confirm that this P lies on the parabola for some theta. And one more thing is that secant is 1 over cosine, tangent is sine over cosine. So this means that if this point is supposed to be a point, a real point, cosine theta shouldn't be 0, otherwise this point is not even defined. Okay, so remember that when you have this point, automatically means that cosine theta is not equal to 0. So it means theta cannot be an odd multiple of pi over 2, yes? Okay, even though this part is not part of the problem, let us investigate really this point lies there. To do that, I have to replace x with that, so it becomes a secant theta to power 2 divided by a squared minus, instead of y, I put that expression for y coordinate, so it becomes this divided by b squared, and then I ask myself, is it indeed equal to 1? You would see yes. Why? Because here a squared and a squared are cancelled, b squared are cancelled, and there is a famous trigonometric identity that tells you that secant theta squared is just 1 plus tan theta squared. So instead of secant, I use secant squared, I put this, and then I have minus tan squared, which is indeed equal to 1, because these two are cancelled. That's correct. Okay, but now my point is to find an equation for the line tangent to this curve at that particular point on the curve. Okay, so I have to, as usual, I have to calculate the derivative, but because this is an implicit function, differentiation process is an implicit differentiation process. So for simplicity, if you don't mind, I really don't like work with fractions all the time, so I prefer to multiply both sides by a squared b squared to get rid of these fractions. So if I multiply both by a squared b squared is cancelled, b squared will go here, and then b squared will be cancelled, a squared will be there, and on the right hand side I will have a squared b squared. Okay, so that is my implicit function. So now I start implicitly differentiating my function with respect to x. B squared is a constant, so this becomes 2b squared x. This becomes minus 2a squared y, but because y is a function of x, according to the chain rule, I have to multiply by y prime as well. But on the right hand side, it's a constant, so its different derivative becomes 0. And so from here, I want to find y prime. So this means that minus 2a squared y prime equals to 2b squared x. Oh, sorry, minus 2b squared x. And then I divide by this coefficient, so y prime finally becomes minus 2 and minus 2 cancel, b squared over a squared, and then times x over y. So this is also implicit derivative because it also depends on both coordinates x and y. Okay. So, of course, this should be valid if I'm also certain about that this y is not 0, otherwise I will not be able to divide. Okay, so now I want to find the slope of the tangent line. So to find the slope of the tangent line, if I call it m sub p, meaning the slope for point P, what I can do, I can just replace x with that expression, which is a over cosine theta, and then I can write for y this, but instead of tan, I can write sine theta over cosine theta. And now what happens, this cosine theta and that cosine theta are cancelled. And then you see that this b cancel one of these b's, this a cancel one of those a's. So what happens finally is that m sub p is equal to b over a, and then I have 1 over sine theta. Okay, so this is m sub p. And now I want to find the equation of the tangent line, which is a very standard exercise. So I would write y minus y naught equals to m times x minus x naught. So I would call it m sub p here. X naught, y naught are any point on the curve. Any point, you can, for writing an equation for the line, it doesn't matter which one you choose, but here it matters that this should be the point of tangency. So I would write it as y minus y naught is this equals to mp, which is this expression, b over a, yes, and then I have 1 over sine theta, and then I have x minus x naught, which is a secant theta. Okay, as I usually told you that I want to get rid of all fractions, so what I will do, so let me write it in this form, b y minus b sine theta cosine theta, and on the right hand side I have b over a sine theta, and this is x minus a over cosine theta. To get rid of all fractions, I multiply both sides by an a, because I want to get rid of that a, by a sine theta, because I want to get rid of this sine theta, and also cosine theta, because I want to get rid of this cosine theta and that cosine theta. So if I do that, the first one simply becomes a sine theta cosine theta y. But this one, cosine theta and cosine theta are cancelled. A and sine theta are left, which will be multiplied here. So it becomes minus AB sine theta squared. And on the right hand side, if you multiply that here, a sine theta cancel, I am left with 1 cosine theta. So this is cancelled. Instead of multiplying cosine theta here, I multiply cosine theta here to get rid of this cosine theta in the denominator. So it becomes x, b is outside, and then I have x cosine theta minus a. Okay. In principle, I am done, but let me just simplify it because that is not exactly the equation proposed by the problem. We have to simplify. So I copy and paste the first term for the time being. And this one, what I can do, I can write minus AB sine theta squared. And then if I multiply this, it becomes BX cosine theta and then minus AB. Okay, let me see. I don't remember what was the equation. So if you see, the equation is BX minus A. So I want to have AB cosine theta on the right hand side and everything else on the left. Okay. So this motivates me to move this one to the left. So I keep this one here, A sine theta cosine theta. Am I recording this? Then I move this one to the left, so it is minus bx cosine theta. Yes, and then what I will do, when I move this to the other side, it becomes positive AB minus AB. I factor a minus AB out, okay? Then from here, positive 1 is left. When it is moved to the right, it is positive, but when I factor a minus sign, it becomes negative. Now probably you understand what was the motivation behind that, because I want to make this appear so that I can replace it with cosine theta squared. Okay? And now do you remember? I told you that if the problem is supposed to make sense, cosine theta shouldn't be equal to 0. But of course, now we realize that m sub p shouldn't also be equal to, sine theta shouldn't also be equal to 0, because otherwise m sub p is not defined. Anyway, so I am on the safe side to divide everything by cosine theta. If I divide everything by cosine theta, this one becomes a sine theta. Okay, if you don't mind, let me divide by minus cosine theta. Okay, so I divide everything by minus cosine theta. This becomes bx positive. This becomes minus a sine theta. Okay, and on the right hand side, I will have just ab cosine theta. So that is the equation of the tangent line. Let me, there should be a y somewhere. Where did I, okay, sorry, this y, I missed that y. So that there is a y here as well. Okay, let me double check that everything is okay. Yes, bx minus a sine theta y, which is exactly this expression. Yes, that is correct. And then equals to ab cosine theta. Okay. Okay, so that is correct. Now we go to the second part of the problem. So let us read it together. This tangent meets the lines x over a equals to y over b and x over a equals to minus y over b at s and t respectively. So if you know about hyperbolas, you know that these are the oblique asymptotes for this. So in principle, it means that this tangent line that we found here is supposed to intersect this asymptote at point S and this asymptote at point T. How is the midpoint of ST related to P? So in other words, we want to find S and T and then find the midpoint of S and T and to see if there is any connection between the midpoint of ST to the point P. Okay, so that is also a very straightforward question. Okay, I mean, there is no twist there, so we know what to do. So let us do it here together on the board. Okay, so let me take one of the asymptotes here. X over A equals to Y over B. And then put it in a system with the tangent line equation that I got there. So it is Bx minus A y sine theta, or let me write it in that way, might be it is better. Okay, so minus A sine theta times y, and then I have equals to AB cosine theta. Yes? Okay, in order to solve this, for example, I can find the AY here. So you see AY is equal to BX. So this means that instead of A and Y, I can put BX. So if I do that, I have a BX here, minus, I will have a BX here as well. Then I have sine theta equals to AB cosine theta. And then I can factor a B from the left and an X from the right here. Of course, the order doesn't matter, but I always care about writing it more beautifully. So I move B from the left, I move X from the right, and I will be left with this expression. On the right hand, oh sorry, there is also an X here. And then this becomes AB cosine theta. Okay, so I will divide everything by this expression. Of course, 1 minus sine theta is also not equal to 0, because if this is going to be the case, sine theta should be equal to 1. So it means theta is an odd multiple of pi over 2. So in other words, if sine theta is 1, cosine theta has to be 0, but we learned that cosine theta is not 0. So we are on the safe side, okay? So if I divide this by that and divide by this expression, x becomes this. But what is this x? According to the problem, this point of intersection is called S. So if you don't mind, after division, let me call it x sub S, make it easier to refer for the future. So x of the point S is equal to a cosine theta divided by 1 minus sine theta. Okay? This is what we get for x sub S. But then if I want to find y sub S, I have to multiply x sub S by b and divide it by a. So when I divide by a, this a is cancelled. When I multiply by b, instead of a, I will have a b. So this means that y sub S is equal to b cosine theta divided by 1 minus sine theta. Okay, so at least we were able to find these 2 points. The point is with these coordinates. Okay, in principle, I have to set up another system for finding t, yes, but that one is x over a equals to minus y over b, and then the equation is bx minus a sine theta y, and then you have ab cosine theta. Okay, so instead of solving everything from scratch, for example, you can introduce capital Y to be minus Y. Okay, so might be we make a little bit of mistake in this way. So let me just do it. Yes. So what do? You would say that Y is equal to minus, again, I would say that minus AY this time minus AY is equal to BX. So here, instead of minus AY, I put BX. And then, because it would be very similar here, this will be plus this time. So let me factor B from the left and Y from the X from the right to save some time. Okay? And on the right-hand side, I will have AB cosine theta. Okay? So instead of minus AY this time, I put BX. So this is the only difference. You will get a plus. And then again, this b and that b, of course, cancel, and you are supposed to divide by this. But because, again, cosine theta is not 0, sine theta cannot be minus 1 either. So I have to divide. I am on the safe side to divide, but because this one is called t, so if you don't mind, let me write x sub t is equal to a cosine theta divided by 1 plus sine theta. And then y sub t will be minus b over a x. So when I multiply it by minus b over a cancel. Instead of a, b appears as before, but of course I will have also an extra negative sign. Yes. So that will be my point T. And then I want to find the midpoint of this line segment ST. So if you don't mind, let me call the midpoint M. Okay, but this is a very famous relation for x sub m. I know x sub m is equal to 1 over 2 x of s plus x of t. Okay, so x of s is here, x of t is here. I want to add them and then divide by 2. But you see that a cosine theta is the same. So to save time, I will copy and paste this 1/2. I also factor a cosine theta out. And then from here, 1 over 1 minus sine theta is left. And from there, 1 over 1 plus sine theta is left. So I have to do a little bit simple trigonometric calculations. So I will copy and paste this first one. Yes, and then here I take the common denominator. The common denominator is the product of them. And then if you compare this one with that one, that is your extra factor. Plus, If you compare this one with that one, this is your extra factor. And then you see that this one and that one are gone. I will get a 2. That 2 will cancel this 1/2, so it becomes a cosine theta. And this is also very famous, so it becomes conjugate rule, so it becomes 1 minus sine theta squared, which is cosine theta squared. And then you simplify one cosine, so it becomes a over cosine theta, and which is exactly a secant theta. But if I ask you what is a secant, you can immediately see that a secant is the x-coordinate of point P. So this becomes x-coordinate of point P. So I was able to show that x-coordinate of point M is the midpoint of line segment ST, is this one. So let us keep it. I have to do very similar calculations for y of M. Let us do that quickly. So y of M, y of the midpoint is 1/2 y of S plus y of T. So this becomes 1/2. This is y of S, this is y of T, but this time they have B cosine theta in common. So I factor that one out. Then the only difference is this minus sign now. So it becomes 1 over 1 minus sine theta minus 1 over 1 plus sine theta. So this time, when I take the common denominator, it becomes 1 over 2b cosine theta. So if you don't mind, let me just do it a little bit faster. This becomes exactly as before, so it becomes cosine theta squared. This factor will go here, this factor will go here, but this minus sign makes this negative, this one positive. So ones are cancelled this time, and I will be left with 2 sine theta. So now what happens? These 2 and that 2 are cancelled. 1 cosine and 1 cosine are cancelled. I am left with b sine theta over cosine theta, which can be written as b tan theta. And then again, you see that b tan theta up there is the y-coordinate of point P. Okay, so this means that the y of the midpoint is also y of the point P. Okay, so these points are the same because the x-coordinates are the same, the y-coordinates are the same, so indeed the point P is the same as point P. Okay, so that is also the next step of the solution. Let us go to the next part of the problem. Okay, so now the point Q is given to you, also lies on the hyperbola. Of course, this is not surprising because if you compare point Q with point P, the only difference is that theta has been replaced by phi. Okay, so that's very good. So we don't need to do much calculations apparently. Okay, and the tangents to the hyperbola at point P, the previous one, and this point Q are perpendicular. These two tangents intersect at x and y, a point with coordinates x and y. Obtain expressions for x squared, y squared in terms of a, theta, and phi. Hence or otherwise show that x squared plus y squared is a squared minus b squared. This is what we want to actually show. Okay, so let us go to the board now. Let me also see. Okay, so we don't need to do the calculation for the tangent line at point at point Q. Yes, do you agree? Because that was the same. The only difference was that I have to switch theta to phi. So if this was the equation for the tangent line at point P, if I just simply replace theta everywhere with phi, I will get the equation of the tangent line at Q. And then I want to find the intersection point between them, which according to the problem is called x and y. Okay, so it means that I have to set up a system. Let me copy and paste this one. So it is bx minus a sine theta y equals to ab cosine theta. Tangent at point P. Tangent at point Q will be bx minus a sine phi. Okay, so if you don't mind, let me write phi like this, it is easier for me. And then y equals to AB cosine phi. Okay, I have to solve this system and find x and y. But be careful. In principle, when you solve it, you find it in terms of a, b, phi, and theta. Yes, but according to the problem, I have to express them in terms of a, theta, and phi. Let me double check. Yes, a, theta, and phi. So it means that I have to get rid of, you see, a, theta, and phi, so I have to get rid of b. So this is something that I have to know. But of course, again, the tangent lines are supposed to be perpendicular. So let me also imply this assumption first before doing other calculations, okay? So what we do, this is the system that I am going to solve. But what is this assumption telling me? You see, this is the slope of the tangent at P, which was this number, but the slope of the tangent at Q will be the same. Instead of theta, I will have phi. So let me just write it here for you. So M sub Q is B over A, 1 over sine phi. But because I know that these two tangents, according to the problem, are supposed to be perpendicular, so this means that if I multiply these slopes, this should be minus 1. Okay, let me write it down. So if I multiply this slope by that slope, b over a, so it becomes b squared over a squared, and then it becomes 1 times 1, which is 1, and then the denominator will be sine theta sine phi. It is equal to minus 1. So what does it mean? It means that b squared, I don't want to have b squared, so this motivates me to write b squared in terms of the other variables that I want. So this becomes minus a squared sine theta sine phi. Okay, so let me reserve it probably for the future and see how we should continue the calculation. I go back to my system and try to find x and y here. So to find, for example, y, I multiply the first one by minus sign and add it here. If I do that, this becomes minus bx, cancels bx, and this becomes positive, this is negative. I can factor a and y out. So let me do that. I take a out from the left and y out from the right. I multiply this by minus sign, so it is positive sine theta left. And I just added the result to this one, so minus sine phi is there. And I have done the same thing here, meaning to multiply this by minus sign and add it here. If I factor AB out, so what is left for me? AB, that will be cosine phi minus cosine theta. Yes. Yes. So this, when I divide y, so first of all, this a and that a are cancelled, I can find y. So y is equal to cosine, it is a b left, cosine phi minus cosine theta divided by sine theta minus sine phi. So this is the y. But I should also be careful that this is not 0. But this is not 0, you know. Because if this is going to be 0, then it means sine theta and sine phi should be the same. But according to this condition, this cannot happen. Because if sine theta and sine phi are the same, so this becomes sine theta squared multiplied by that squared. So it is a non-negative number. It's a positive number. And then because of that one is minus. So that if they are supposed to be equal, the right-hand side is negative, the left-hand side is positive, so it is not possible. So yes, we are on the safe side. We can safely divide by that. Okay, now I have to find x. I don't know which one is more suitable for x. I would recommend, I don't know, I would probably put this one in this here and then try to find x. So let me do it here. Or is it better to do it the other way around? Okay, that is also good. So for example, let me multiply this one by minus sine phi, and let me multiply this by sine theta and add them up. Okay, so if I haven't done any mistake, if you multiply this here, it becomes plus a sine theta sine phi y. This becomes negative a sine theta sine phi y. When I add them, that's cancelled. That's good. And then this will be multiplied here, this will be multiplied here. When I add them up, I can factor b and x out. So it becomes sine theta minus sine phi. Yes. And then I also have an x here. Now, that was probably a little bit simpler. Okay, and then remember, this is multiplied here, this is multiplied here. I also have to add them up. AB is in common, so I factor AB out. And then I would write the positive one first, which is sine theta cosine phi minus sine phi cosine theta. Okay? And then you see that this b and this b is gone. And what do I get for x? X is sine theta cosine phi minus sine phi cosine theta. And I divide, oh, there is an a left here, so let me put a there, and then I divide by that expression. Okay, so in principle, the first time that I solved the problem myself, because this is a very famous formula, I wrote it as sine theta minus phi, because that is the subtraction formula for sine. Then I realized that, I'm not sure, the way that I did it, it didn't work like this. So this is based on the experience I had from previous solution before recording the video. I realized that let me keep it like this. It was not very evident for me back then. Okay. Okay, so now what we are supposed to do, we are supposed to calculate x squared and y squared in terms of a phi. So I want to calculate x squared, y squared, and finally, of course, the sum of them. But I want to write them in terms of a, theta, and phi. And I also want to show that this is a squared plus b squared. Okay, so that is my final goal. Okay, so I think what we need is this relation and of course these two relations. So if you don't mind, let me pause the video and clean the board, write them more organized, then I will come back to you again. Okay, so we continue. So these are the informations needed. Of course, writing x squared, x is already in terms of a, theta, and phi. So x squared is just this one squared. Okay, and y squared becomes b squared and something in terms of phi and theta squared, but we know b squared can also be written in that. So it's writing x squared and y squared in terms of those parameters is just raising them to power 2 and use this one. So if you don't mind, let us just solve the last part of the problem. So we want to prove that x squared plus y squared is a squared minus b squared. Oh, I wrote a squared plus b squared. No, the correct version is a squared minus b squared. We want to prove this one. Okay. So let us try to calculate xy squared plus y squared. So you see here what I have. The good news is that the denominators are the same. So when I square them, I will have the square of these denominators. I can factor it out. Yes. So this becomes sine theta minus sine phi squared. When I square this one, I will have a squared. Okay. But when I square this one, I will have b squared. Okay. So, and b squared is this expression. So then you will see that I will have a squared in common. So I can pull a squared out as well. Okay, so we have to be careful hopefully we are not confusing ourselves. Okay, so imagine that I have raised this to power 2. There is a b squared. That b squared is replaced by that one. Okay, so this means that this one also has a squared. So I pull a squared out. But what happens? This one will be to power 2. Yes. And this one will be minus cosine phi minus cosine theta to power 2. Yes. Let us double check everything. So when I raise this one to power 2, this is to power 2, this is to power 2, I pulled it out. When I raise this one to power 2, you see this factor here. When I raise this one to power 2, you see this factor here, but this becomes b squared. Oh, sorry, I made a mistake, so that's good that we checked. B squared is minus a squared sine phi sine theta. So there is a sine phi sine theta also involved here. Yes, that's good now. Yes, hopefully understandable. Okay, there is nothing apparently I can do here, so let us continue and then try to see what we can do here. It is not hopeless. You see here, when I tried the first time, I wrote the formula for it. But here I can see that when I raise this one to power 2, the combination of minus 2 times sine, sine, cosine, cosine appears. And when I raise this one to power 2 and then multiply this in, the same expression with opposite sign appears. So that was the reason I realized that it was not a good idea probably to write this in terms of the subtraction formula for sine. So what I will do, I would write a squared over sine theta minus sine phi to power 2 and then raise it to power 2. So it becomes sine theta squared cosine phi squared plus or minus 2 times the first one times the second one. And then plus the second one squared. Okay? And then I raise it to power 2 and multiply it by minus and this combination. So let us do it together. So it becomes minus sine theta sine phi cosine phi squared. The next one becomes minus 2 times the first one times the second one. There is a minus, it makes it plus. So it becomes 2 cosine phi cosine theta, but you should also multiply it by that. So that was my motivation actually to do this, because I see that this bigger term is all going to be cancelled. And then finally the last one becomes again minus cosine. So let me write it the same order. Sine theta sine phi, and then I will have cosine theta squared. Okay, this is what we have now. And as I told you that this term here and that term are cancelled. So let me write it a little bit organized to see what we can do. So this becomes a squared over sine theta minus sine phi squared. Okay. Then I realized that, because you know that I know what I'm going to get. I'm going to get, according to the problem, a squared minus b squared at the end. So this means that this factor should definitely go away. Okay, so that is the motivation, what I'm going to do. So, and this combination is only a combination of sines, not cosines. So this motivates me to try to get rid of cosines as much as possible. So for getting rid of cosine here, there is one alternative. So let me write it. So I would write sine theta squared, and then here I would write 1 minus sine phi squared. Okay? And the same happens for this term. I want to get rid of this cosine as well, so I would write sine phi squared 1 minus sine theta squared. Okay, and then let us see what is left for me. I am left with this one and that one. So let me see, because I want to make that combination. This needs sine theta squared sine phi squared, which I will get from here, but 2 times sine, okay. So I need minus 2 sine theta sine phi to appear. So let me just put it by hand here. But of course, I have to add to compensate for that. Okay. And then for the time being, let me copy and paste the rest. Okay. So you see what is my idea? My idea is that I know I should reach to a squared minus b squared. So in principle, I have to get rid of this combination. So I am trying to factorize this expression in a way that it gives me this so that I can get rid of it. I did a lot of trials and errors. Still, I don't remember it exactly. I have to think again. So, but what I did, because of that, I see that there is no cosine. So I got rid of this cosine in this way. I got rid of that cosine in this way. And then I know that a sine theta squared is coming, a sine phi squared is also coming, but I want to have this combination, so I need minus 2 sine. So I subtracted it, and to compensate for that, then I added. For the time being, I copy and paste. Did I copy and paste the rest? No. There is also a cosine theta squared. I forgot. Okay. So let me continue to see how it goes. So then it becomes a squared over sine theta minus sine phi squared. Okay, so then sine theta squared plus sine phi squared minus 2 sine theta sine phi can be collected into the form of sine theta minus sine phi squared. That's good. But what is left? This multiplied by that is left. It's minus sine theta squared sine phi squared. And then this one is also left, which is 2 times that, because they are the same now. Yes, so I put a factor of minus 2 there. And then this is already taken care of here, but this one, and that one are also left. So let me write them down. So it becomes plus 2 sine theta sine phi, and then I have minus sine theta sine phi cosine phi squared minus sine theta sine phi cosine theta squared. Okay? Okay, in order to be able to get rid of it, I also need this factor appear in the rest because I want to factor it out. So do you see any way to do it? First, I have to make sure that I haven't done any mistakes. Apparently not. Okay, so if you see here, I can factor. Okay, so I should have done this before. Okay, so if you don't mind, let me here factor this minus sine theta sine phi from here. And I don't know why I didn't do that, because that is also reasonable. Okay. Yes. Okay, let me do it again. So this becomes equal to a squared over sine theta minus sine phi squared, and then sine theta minus sine phi squared, and then let me see if it is a good idea. Yes, if you don't mind, let me take this one, and this one, and put, yes, I will pull sine theta sine phi out. Yes, you see why? Because there will be a 2 left here. There will be a minus cosine phi squared left here. There will be a minus cosine theta squared left here. Okay, and then you know that I also have that one, so I should copy and paste that for the time being to see what happens. Yes, and then now the good news is that I can borrow one of these ones and give it here. It gives me sine phi squared. I can borrow the other one and give it here. It gives me sine theta squared. So this is nothing except sine theta squared plus sine phi squared, which is a good thing, you know. So what happens, this becomes a squared over sine theta minus sine phi squared, and this one I copy and paste. Okay, so as I told you that this expression can be written as sine phi squared plus sine theta squared. Okay? Okay, and then now between these two, I factor that and then I am done. So you see, this multiplied by that minus that one. Sine theta, sine phi from this combination and from this combination can be pulled out, yes? So it becomes plus sine theta, sine phi. And then from here, this combination is left, sine theta squared plus sine phi squared is left. And very nicely, I have the combination I need because there were powers of 2. I pulled one of them out, so one of them will be left here. And I hope that you can already see and you are already happy that it is done. Why? Because that is exactly the combination that I need, sine theta minus sine phi squared. So I have sine theta minus sine phi squared. I have this multiplied by that, but that is good because I can factor this expression out, and as I designed for it, I can get rid of this finally. Okay, so let me write everything patiently. So this becomes sine theta minus sine phi squared. I am pulling this sine theta minus sine phi squared out. From here, 1 is left, and from here, plus sine theta sine phi is left. I'm a little bit worried about okay, so let us not jump forward. Okay, so this one and that one are cancelled. What do I get? I get a squared. Yeah, that's correct. This is a squared and 1 plus this combination. But look, this combination is b divided by minus a squared. So instead of that combination, I can put minus b squared over a squared. And finally, we multiply it, so it becomes a squared minus b squared. And that is exactly what we wanted to show. So we started the calculation here, x squared plus y squared, and then we ended up here. So it means that this is indeed correct. Okay, might be you can find a better way to do this, but more or less, because I remember I did it once on live, so I tried to I managed to do it, but I thought that might be it is not a good idea to upload that video because I was thinking loudly myself to find the way. Then I realized that I should make the video so that you are not at least confused. But still, I believe that I made a little bit of confusion here for you. So if that happens, sorry for that. Anyway, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.